Welcome to this tutorial on NumPy Error Handling. In this video, we'll explore how to effectively manage exceptions and errors that occur during NumPy operations. Understanding error handling is crucial for writing robust and reliable code that can gracefully handle unexpected situations. Let's begin by examining the most common errors you'll encounter when working with NumPy. Value error occurs when you try to perform operations on arrays with invalid shapes or incompatible dimensions. Index error happens when you attempt to access elements beyond array boundaries. Memory error occurs when there's insufficient memory to allocate large arrays. And type error appears when you use incompatible data types in array operations. The fundamental approach to handling NumPy errors is using the try-except pattern. In this example, we import NumPy and create an array with values 1, 2, and 3. We then attempt to divide this array by 0, which would normally cause an error. By wrapping this operation in a try block, we can catch the runtime warning and print a custom message. We also include a general exception handler to catch any other unexpected errors that might occur. Shape mismatches are among the most frequent errors in NumPy. Here we demonstrate how to handle them properly. We create two arrays. Array A is a 2 by 2 matrix, and array B is a one-dimensional array with 3 elements. When we try to add these arrays together, NumPy raises a value error because their shapes are incompatible. By catching this specific exception, we can provide a meaningful error message that helps identify the problem. NumPy provides a powerful function called seterr that lets you control how errors are handled globally. In this example, we configure NumPy to issue warnings for division errors and raise exceptions for invalid operations. When we divide an array by 0, NumPy prints a warning instead of raising an exception. However, when we try to calculate the square root of -1, it raises an exception as configured. The seterr function accepts 4 different options for controlling error behavior. The ignore option suppresses all warnings and errors completely. The warn option prints a warning message to alert you of the issue. The raise option raises an exception that stops program execution. And the call option allows you to execute a custom callback function when an error occurs, giving you complete control over error handling. For temporary error handling settings, NumPy provides the ErrsState context manager. This is particularly useful when you need different error handling for specific operations. In this example, we use ErrsState to ignore division errors within the context. We divide an array by 0, which produces infinity values without raising an error. Once we exit the context manager, the error handling settings automatically revert to their previous state. Proactive validation is a best practice for preventing errors before they occur. This safe divide function demonstrates input validation. First, it checks if the 2 input arrays have the same shape, raising a value error if they don't match. Then it uses np.any to check if any element in array B equals 0, raising a 0 division error if division by 0 would occur. Only after passing these checks does it perform the actual division operation. When working with large arrays, memory errors are a real concern. This example shows how to handle situations where array allocation fails. We attempt to create an extremely large array with dimensions 10,000 by 10,000 by 10,000, which would require enormous amounts of memory. When this allocation fails, we catch the memory error and implement a fallback strategy, creating a smaller array instead. This approach allows your program to continue running even when memory constraints are encountered. Let's recap the key best practices for NumPy error handling. Always validate array shapes before performing operations to catch incompatibilities early. Use the ErrsState context manager for temporary error handling when you need different behavior for specific code blocks. Catch specific exceptions rather than using generic exception handlers, as this makes your error handling more precise and informative. And finally, always handle memory errors when working with large array operations to prevent your program from crashing unexpectedly. Following these practices will help you write more robust and reliable NumPy code.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.